last lesson, we have the lesson 1. You have learned about the standard normal distribution. In this lesson, we will be focusing on the lesson 2 with the areas under the normal curve. Are you now familiar using your z-table? Is it easy for you to find for the probability value? Here are some z-values which are needed to find for their probability values.
For number 1, we have z equals 1.19. So we will use our positive z values. First is to locate for the 1.1. 1.1 is located on this part. And for the second, we need to locate 9 on the horizontal values. And it is located on this part. So their intersection would be the probability value. That is 0.88298. For number 2, we have z equals negative 0.26. Since it is negative, we will use the negative z values. So negative 0.2 is located on this part. And for 6, it is located on this part. So their intersection would be 0.39743. And for number 3, we have z equals 0.69. It is positive, so we will use the positive z values. So 0.6 is located on this part, and for 9, it is located on this part. So their intersection would be 0.75490. For number 4, we have z equals 3.921. 3.9 is located on this part. 0.01 is located on this part. So their intersection would be 0.99995. Next, we have a number 5. Z equals 3.01. 3.0 is located on this part. 0.01 is located on this part. So their intersection would be 0.99869. Okay, for number 6 to 10, you can do it by yourself. For number 6, z equals negative 1.77. Number 7, z equals negative 1. Number 8, z equals 0.62. 9, we have z equals negative 2.34. And for the last, we have z equals negative 2.73. Areas or the probabilities for the standard normal curve are present on the standard normal table. You can see that on this appendix, table 1A and table 1B. Take note that the table values represent area to the left of the z score. Example number 1. Find the areas under the standard normal curve which lies to the left of 1.01. So we will use now our normal curve, or that is the standard normal curve. We will use also the z-table. So the situation here is to the left of 1.01. First step is to locate 1.01 under the normal curve. So assuming that it is located on this part. Second is to locate 1.01 to the table. So 1.0 and 1, so their intersection is 0.84375. Do you have the same answer like me? Okay, very good. So this is now the area to the left of 1.01. Okay, for the second example, to the right of z equals 0.95. Okay, first step is to locate 0.95 under the normal curve. So assuming that it is located on this area. For the second, we need to use our z table. So the area to the left of 0.95, since our situation on our table is to the area to the left of the 0.95, so 0.9 and 5, so the intersection is 0.82894. But this table represents the area to the left of z-score, and our situation is to the right of 0.95. Always remember that the total area of a normal curve is 1. So in order for us to get the area to the right of 0.95, so we will deduct the probability value to the left of 0.95 from 1. So 1 minus 0.82894 equals 0.17106. So if we are going to shade for the area to the right of 0.95, so we have this area to the right of 0.95. Another example we have between z equals 0 and z equals 1.4. First step is to locate z equals 0 under the normal curve and z equals 1.4 under the normal curve. Second step is to locate for the probability values. So the probability value of 0 is 0.5 and the probability value of 1.4 is 0.91924. So let us shade for the areas to the left of 0 with color green. And let's shade color yellow to the areas to the left of 1.4. Okay, as you can see on the shaded part, there is an overlapping of colors. And our situation is to locate for the areas between the two z values. So what are we going to do? Okay, very good. So we will deduct the area of 0 from the area to the 1.4. So 0.5, so since it is 0.5, so we will deduct this from the area of 1.4. So 0.91924 minus 0.5 equals 0.41924. So this is now the area that we need. So we have 0.41924. Now it's your turn. On page 18, once more, find the areas under the normal curve which lies
Since you are done, good job. I hope you have learned something today.